So today we're gonna start substitution method. Do you have any idea about substitution method? Yeah, it is about putting not a number basically. It is first we need to simplify a question, make subject of the formula. For example, if uh, we have two equations and those equations are in variables x and y, then we need to find x from any x or y from any of the equations. It depends upon us. Then we submit those value in the second equation. We can make subject of the formula from the first equation or from the second equation. It doesn't matter. But we need to make sure if we are getting the value from equation 1, then we need to substitute that in equation 2, or if we are getting that value from equation 2, then we need to substitute that value in 1. We cannot substitute the value from the same equation. If we are getting the equation from 1, okay, then we cannot substitute that in the same equation. Okay, so this is also a very simple method. We just need one or two more steps than the elimination method. Both have both are both are easy, by the way. Sometimes students found elimination method more easier than the substitution. Sometimes some of the students found substitution method easier than the elimination method. So but they're almost same. So let me start with the question. Okay. So first of all, I'm taking a very simple example, substitution method. Sorry, I have not shared my screen with you. Yeah, is it visible to you now? Perfect. Substitution method. Okay, we got a question here, and you can solve a same question with substitution method or elimination method. It means like you can solve all those question which you solved using elimination method by substitution. And the answers will be same. Only there is a difference in the method. So can you please suggest any two equations, two linear equations? 3x add 3 equals to, yeah, we need a complete equation. 7, right? So we need such equations, like we need a linear equation with two variables. Okay, like now this equation is only one variable, so I'm just replacing this 3 with with the second variable. For example, let's say this is 3x plus y equals to 7, so this is equation 1. So what should be the equation 2? 5x add 2y is equals to 6. This is equation number 2. So here these both are two linear equations with two variables, and we can solve them using elimination method or the substitution method. We're gonna uh, do the substitution method today. So what is substitution method? Again, as per in the elimination method, we have two equations and you can target equation 1 or 2. Okay, so what we need to do is always try to target that variable which have coefficient 1. You know about coefficient now? Yeah, the constant with the variable. So always try. You can target any variable, x in the first equation or x in the second equation or y in the first or second equation. It doesn't matter. But always prefer to target that variable which have coefficient 1. So why is it so? Like if, for example, if you say, so I'm not I'm gonna target this 3. So basically what we gonna do in substitution method is we need to separate this variable now. The targeted variable should be separated. So this will be like 3x equals 7 minus x, sorry, y. And then x will be 7 minus y upon 3. We can separate this. We can make x as a subject of the formula. But why I'm saying that preferably we should target y. See here. If I make this y subject of the formula, then the equation 1 will be like y equals to 7 minus 3x. So compare these both equations. This is a straight equation, like linear equation. And but in this we got a fraction, and we always try to avoid fractions. We can solve using both. Like we can substitute this x equals to 7 minus y upon 3, but preferably we avoid fractions. That is why I'm saying that try to target that variable which has coefficient 1. So in the first equation, y has coefficient 1, so I made y subject of the formula, and this is now equation number 3. So we got this value from equation 1. Now I can only substitute this value in equation number 2. Do not use the value in the same equation. You will get nothing. Like if you substitute this y in the same equation in equation 1, you will get 0 and you cannot solve it. So that is why please try to make sure if you're getting the value from equation 1, then substitute that in the equation 2, and if you're getting value from the equation 2, then substitute that value in equation 1. Perfect. Okay, so substitute equation 3 in equation 2. So this is the value of y. So 5x add 2 times 7 minus 3x is equals to 6. Now simplify this equation. 5x times, sorry, add 2 7 times, yeah, it's 14. 2 7 times. No, it's 5x add. Then this 2 will get multiplied with this whole factor. This 2 will be multiplied by 7 and 3x. Is it right? Yeah. Then this positive and the negative will be plus, into minus will be minus. 2 3 times 6x equals to 7. Now simplify the like terms. We have two terms containing x on the left side. So 5x minus 6x, 6 minus 14. So what will be the 5 minus 6? Minus 1x. And what will be 6 minus 14? Minus 8, and x will be 8. Okay. So now we are left with y. So we have three equations. You can substitute this x in either of the equation, in equation 1, 2, or 3. So I'm putting this in 3. Put in equation 3. So by using this value in equation 3, we can have y. Y is equals to 7 minus 3 times 8. So this is now y 7 minus 24. Y is 7 minus 24 will be minus 70. So can you please check whether these values are correct or not? Is there any method to verify this? It's positive 8. Yeah, can you please do it for me? Just in 5 seconds. I'm just trying to say that please substitute these values, verify these values. Either these are correct or not. 8 and minus 17. Yeah. So now we have this question, and in this question again we are having two linear equations. So what you say? Uh, which variable should be targeted in these equations? X. Okay, as all the variables have some coefficients, so you can target any of the variable x from one first equation or the second, or you can target y from the second, from the either equations. Okay, so as you're saying that we should target x, so x from the first or second. Okay, we can start by the second equation. So this is now from equation 2. So I should write, just correct me if I write something like if I write something wrong. Okay, so 4x plus 5y is equals to 42. 4x is 42 plus 5y. So I'm doing it correctly. So yeah, I should change this sign. Perfect. So this should be negative. 42 minus 5y, we need x. So it will be 42 minus 5y upon 4. So this is our equation number 3. So now what will be our next step after getting this value? Yeah. Why should I do this? To not split this fraction. Just like this is our equation number 3. What we need to do after getting this equation? What we did in the previous, let's check the previous question here. So this was the previous question. What we did after getting third equation? Can you please check this out? This is equation number 3. So here, this is equation number 3. After getting equation 3, what we did? Yeah, substitute this equation 3 and substituted this equation in equation 2. So is it mandatory to substitute this in equation 2, or there is any other requirement? Why not? Like why did like can I substitute this in this equation, in this question? Can I substitute this value in equation 1 or not? Why? I told the reason. Please try to recall that. So do you remember this? There is a reason. Okay, but you remember that there should be a reason, right? Okay, the reason is when you are finding a variable or making a subject of the formula from any of the equation. Let's say you are making subject of the formula from first equation, then you cannot use the value in the same equation. If we use the value in the same equation, we will get 0. Okay, so now in this question, in second, now tell me, what should I do now? Yeah, substitute this in first equation. So substitute equation 3 in equation 1. So by substituting this in 1, this is the value of x. So 2 times 42 minus 5y upon 4 minus 7y equals to 2. So now just simplify this now. Can I cancel this? 2 and 4. Sorry, it's 2 times. So the new equation will be 42 minus 5y upon 2 minus 7y equals to 2. So we got fractions here, and we can solve these fractions using LCM by taking LCM. Yeah, yeah, exactly. And simplify this. So now this will be 42 minus 5y minus 14y upon 2 equals 2. Can I multiply this? Can I shift this 2 on this side or not? So if I shift this 2 on the right side, so should I add this, subtract this, or multiply this? Yeah, because it is in the denominator. When I need to shift this on the right side, it should be multiplied on the other side. So this will be minus 5 and minus 14 will be minus 19y equals 4. We need y here, so it will be minus 19y times 4 is minus 42, and minus 19y is, it's 38, and y will be minus 38 upon minus 19. Should I change this negative sign here by shifting 19 on the other side or not? Why should I change this? I changed, like, this 19 was getting multiplied with y. Okay, so when I shifted this on the right side, it is in the denominator now. So now it's dividing, so the multiplication sign is changed into division. So when we shift any number which is getting multiplied on our side, on the other side, then we do not need to change any positive or negative signs. Okay, yeah, when a number is getting like add on the one side of the equation, when we shift this on the right, it is changed to the negative sign, and when a number is getting subtracted from the one side, when we shift this on the other side, it it's changed to the positive sign. Similarly, when a number is getting multiplied, it should be changed into the division, or when a number is dividing anything in the fraction, when we shift this on the other, it get multiplied. Okay, so the answer will be y equals to. So we got two answers. The value of x is here. So now, sorry, we got only y here. We need to find x. For x, what we need to do, we need to put this value, this y equals to 2, in any of the equations. So I am putting this in third equation, Put y equals to 2 in equation 3. Now you are not bound to put this in equation 1, 2 or 3. You can use this value in any of the equations. Am I clear to you? It's 2. 38 divided by 19. Acha, okay, x is equal to 7. So let me check it. X is 42 minus 10 upon, yeah, it's 8. So x is 8. So this question is from the past papers. Okay. So you checked it. You can in the past paper like they do not mention there to solve it using elimination method or the substitution method. So you can apply any of them. Can you please tell me what is your course code for this maths? It's 0580 or 4024. What is the course code? You know about it? Yeah, there is a paper code for your this subject. You know about it or not? Okay, it's GCSE, right? You're appearing from the GC board. Uh, if you check any of your past paper or the worksheet or any if you appeared in any of the test from the your teacher or instructor, there will be a code mentioned on the paper or the test or the worksheet or the book if you have any book. So the code should be 0580 or the 4024 or 4027. So try to find that and just tell me so that we can practice questions related to those papers for more accurate practicing. So if you have any if you got any questions related till now, you can ask please in these two questions. This question is from the past papers. Okay, both methods are easy. Like which method is more easier? Like elimination method is more easy or substitution method? What you say? Ah, yeah, perfect. Basically, in these equations, you just need to make subject of the formula from any of the equation, then substitute that in equation and solve it. In elimination method, sometimes we need to like we may face some problems uh, when we have different coefficients and we need to make them same by multiplying with some numbers with different numbers. We need to multiply, then simplify, then add or subtract, then we need to change the signs and all the things. But there is no need to do a lot of work in substitution method. So if you're pro in substitution method, that is perfect. There is nothing like restrictions. There are no restrictions in the paper. Sometimes they do mention that use this elimination method or substitution method, but sometimes they just give us equations and write solve these equations simultaneously, or just find the answer, or you will be given with a word problem and you need to make the equations and simplify those using either of the methods. So let me solve one more question, but I'm gonna write two more equations here. But in the third question, I need you to be a teacher and I will be your student. So you will be guiding me and I will be writing on the board. 3x plus 4y equals to 14. So this is question number 3, and the equations are 3x plus 4y equals to 14. This is equation number 1. And the second equation here is, sorry, 5x plus 2y equals to 21. It's 5x plus 2y equals to 21. This is the second equation. So do you have any question related to these equations, or should we start? Okay. Okay. Okay, from equation 1. Perfect. Okay. Okay, perfect. Divided by 3, and this will be our equation 3, right? Sorry. Thank you. In the bottom equation, so substitute in equation 2. So it will be 5 divided by 3. Next, you just substituted this value here. Write the rest of the equation as it is. So plus, so now we just need to simplify this. So can I cancel this 5 with 3? No. So just multiply this with 14 minus 4y. So 14 times 5 will be, no, it it like 770. We have the number in tens. Yeah, the number is in tens. Okay. No, we don't need to multiply the bottom. The 5 is in the numerator. So just need to multiply with the numerator. There is nothing in the bottom of 5. So there is 1. So 1 times 3 will be 3. Yeah. Now 20 with 3. No. You cannot multiply 21 with 3 in this step. So to multiply this, there should be a 3 in the whole fraction. Like there should be a single fraction here. Then you can multiply. Yeah. 2y over 1. Yeah. So it will be 70 minus 20y plus 6y upon 3 equals to 21. Now you can multiply this 3 on the right side. Yeah. It's 63, and what will be here? 70 minus 14y. Excellent. No, you multiplied this 3. Yeah, yeah, it's fine. Okay, okay. That means y is equals to 1 upon 2. Yeah, so that is great. You did it in a very good way. It's 1 upon 2. So now we are left with x. So how we can find x here? Always try to substitute in the third equation, because already we have x here. We don't need to shift any variables on the left or right side of the equation. If you can use this value in the top equation, it doesn't matter, it doesn't change any answers. But if you use this value here, let's say you're using this in the top equation, you're putting this value here, then you're shifting this on the right side, or this on the right side, then you're solving it, then you're multiplying this, dividing this 3 on this, and you are increasing your steps. You already made this x subject of the formula in this equation. We already did this. Just put the value. Always try to, when you succeeded to find any of the variable x or y, then always try to put that, preferably, like, it doesn't matter, it is not mandatory to put that in the equation 3, in the third equation, but it is fruitful for you. It saves your time, it saves your space. Okay. Now, x is equals to 14 times 4 into 1 upon 2 upon whole fraction 3. So this 2 into 2. So this is now 14 minus 2 upon 3, which is 12 upon 3, which is 4. So this question was again from the past papers. Now we will solve a word problem here. And firstly, uh, please be attentive. I'm gonna write a statement here, and I would like you to make to convert the statement in the equations. So let me write the equations here. Okay, so we are here with a word problem. This is question number 4. Word problem. So the statement here is, so Ruby pays $10.80 when he buys 3 notebooks. Ruby pays $10.80 when he buys 3 notebooks and 4 pencils. 3 notebooks and 4 pencils. Okay, Paris pays $14.50 when she buys 5 notebooks and 2 pencils. Now she is paying 14.50, pays $14.50 when she buys how many notebooks? 5 notebooks and 2 pencils. And 2 pencils. So what we need to do here is write down simultaneous equations and use them to find the cost of a notebook and the cost of a pencil. This is in May-June 2023. This question is from the past paper of May-June 2023. May-June series 2023. So what will be the equations? Yeah, we can like, let's say, let we can consider that notebooks is X and pencils, we can represent these pencils with Y, right? Okay. Okay. So you can use any of the methods, elimination or substitution method. But as we are doing substitution method today, uh, so we should apply the same. We will solve this using both methods here. So first, I need you to guide me to solve it using substitution method. Is there any problem with this? If we got decimals here, to double it, like to double 10.80, we can, like, it will be 29, but we do not need to do that. Okay, well, like, why should we create difficulties for us, like, as we can solve it using the same values? Why should we increase these, as at the end we're gonna simplify these? After all, we're gonna simplify these, huh? So why should we, like, multiply with 2 or any? Let's say if you multiply the second equation with 2, okay, you will, like, you can get rid of the decimal. But what you will do in the first equation? You need to multiply to get rid of the decimal. You need to multiply the first equation with 10 or 100. You said that to avoid these decimals we can multiply the bottom equation with 2, right? So I'm saying, then what we need to do with the first equation? How you can get rid of decimal in first equation? By multiplying with 2, 3, 5. What you say? So it will be 10.80, so it will become 21.6, I think so. It's again a decimal. Yeah, you can then you should multiply with 10 or 100, but we do not need to waste our space or waste our time. We can solve, still we can solve it. It is not much difficult. uh, you just need to do some like calculator work. If you are allowed to use a calculator, then you're good to go. If you are not, let's say we have a solution here. If you forgot to take your calculator in the exam, let's say, or if your calculator stopped working, or if you are not allowed to use calculator, we have any situation. So then how you can like eliminate, yeah, you can get rid of this decimal. Let's say this is just a rough work to like, just to make you understand how you can avoid. Let's say I have the first equation here, uh, which is 3x plus 4y dollars 10.80. So if I eliminate this decimal, we got 1 here and add 2 zeros. So you got it? So just, this is a single fraction on the right side. 100 is in the division. Now multiply this 100 with on the left side. So you like, by doing this, you can save your time in hit and trial method. Like, in thinking that you were saying previously that we can multiply by 10 or we can multiply by 100. Yeah, before telling me that so we can multiply with 10 or 100. You were thinking about it, we should multiply by 2, or so we can avoid all these things. Just eliminate that decimal, replace the decimal with 1 in the denominator, and add the zeros for rest of the numbers or the digits. Okay, so now we have the single fraction on the right side. Multiply this 100 with on the left side, so it will be 300x, 400y, 1080. Or there is another option. There is another option. You can simplify. If it's possible, you can simplify here. You can cancel this. Now this is 108 over 10. You can again simplify this to 5 times to 54. Now multiply this 5 on this side. So the new equation will be 15x plus 20y equals to $54. You can do this. You can solve to using this, like using this equation now. So you're getting my point? You, yeah, exactly. You can have the same answers. So you can convert. So what we did to get rid of this decimal, I just simplified this equation and we got a new equation which is 15x plus 20y equals to 54. Similarly, you can do the same with this equation, and this will be like 10x plus 4y 29. You can solve these equations now. Like, you can use substitution method. As we are doing substitution method, I would prefer to use the substitution method. So this is, let's say now, this is equation 1, this is equation 2. So what will be the what will be the next step? Yeah. So I should use 1 or 2. 2. And I should find y or x. X. Um, okay. From equation 2, as we are short of space here, so I'm just gonna write this directly. So x will be $29 minus 4y upon 10. Are you good with it? Okay. So now substitute this equation 3 in equation 2 or 1? In 1. Why? Because we are getting this value from 2. We cannot substitute in the same equation. So put in equation 1. Let me move to the next slide. It's 15 times 29 minus 4y upon 10. It's 15 times 29 minus 4y upon 10. Then plus 20y equals to 54. Plus 20y equals to 54. So can we simplify this 15 and 10 by 5? So it's 2, it is 3. Now just multiply this 3 with these numbers in the bracket. 29 3 times is, I think so, 87. Please check it on the calculator. Minus 12y upon 2 plus 20y. There is nothing in the fraction. It means it's 1 here. So it's 54. We need to take LCM by multiplying 2. So it will be $87 minus 12y plus 20 times 2 will be 50. Oh, it will be 40. 22. Yeah. So just try to be active in the class. Okay, it's 40y upon, do not trust your teacher blindly. So you yeah, you learned a new lesson today. Accept mess. Do not trust your teacher blindly. So teacher may make mistakes, and sometimes they could do something like this. So this is, now we can multiply this 2 with 54. So on the left side we have 87 plus, it's 40 minus 12, 28y equals to, what is 54 times 2? Yeah, yeah, it's 108. Yeah, it's 28y, and 108 minus 87. So what will be 108 minus 87? It is 21. Okay, so 28y is equals to $21, and y is 21 upon 28. Can we simplify 21 and 28? With 7. So the answer will be 7 3 times and 4 times. And now put this in the equation 3. Put in equation 3. So what was equation 3? That is, where is the, yeah, here it, x, no, third equation is x equals to 29 minus 4y upon 10. So we can put these values here. X is 29 minus 4 times 3 upon 4. Yeah, divided by 10. It's 3. And it will be 26 upon 10. 29 minus 3 will be 26, and it will be $2.6. Can you please tell me what will be 3 upon 4? I think it should be 0.75. 0. Can you please check these values? Either they are correct or not. On the left side, okay, just give me a second. uh yes, here you can use, put it in the second equation and check whether the answer is 29 or not. So perfect, it means we did it correctly. So yeah, we know. Yeah, Yes, if we opt for the elimination method. Yeah, that is elimination method. So sometimes in this question, if you solve this, so I will email these slides to you, and try to solve the same question using elimination method. And I think so you will found elimination method good for this question, this word problem. So so when you know about both methods, sometimes for some questions elimination method is good, like that is more preferable than the substitution method, and for some questions substitution method is good as compared to the elimination method. So you need to learn both methods, and there are pros and cons of both methods. Like sometimes you found substitution method easier, sometimes you found elimination method easier. So uh, let me recap my lesson here. uh, just and I shared the uh, like schedule for the whole month. So if you need any changes at any time, like it is almost at every Saturday of uh, January. So this was the second class of the Jan, and then we will have the next class on, I think so it will be 20th or the 21st. So I mentioned in that email, try to acknowledge such emails when I shared any schedules or something, so that I may know that you are like you received it, you read it and you acknowledged it, so that as it was good, you are on time today, so it saved our time. So in today's lecture, we are done with the substitution method. Basically, we have I told you about three methods to solve simultaneous equations. The first one was elimination method. The second one is substitution method, which we did today, and the third method is basically graphical method. So actually, the reason why I was asking you about your paper code, so that I get to know about your syllabus, and so that we can do the topics accordingly, to avoid any extra. Let's say if your code is different, and there is no need to use graphical method to solve simultaneous equations, so then we will not be like spending our time on the graphical method, which is easier. Like we just need to use these equations, and to make the tables and use some two or three different values and plot the graphs on the graph paper. Yet like this is x, this is y, and join those points, we will be getting two straight equations. whenever we Whenever we plot a graph of a straight line, this is a linear equation. You can like by name, this is a linear equation. So whenever you plot a graph of a linear equation, it comes from the word line. Linear comes from the word line. So whenever you plot a graph of linear equation, you will get a line, a straight line. So if I solve the same question, we can solve this, like we can solve simultaneous equation as the same question with three methods: by elimination, by substitution, and by graphical method, and the answers will be same. Sometimes we may have approximate answers using graphical method. If you like doing it correctly, like you are taking the measurements accurately on the x-axis and the y-axis, you will get the exact answers. If as we got 0.75, and I think so the first was 0.75, and what was the second at 2.6, I think so. In the last question the answers were 0.75 and 2.6, I think. Yeah, so we can get the exact answers using graphical method, but we may make some mistakes in the measurements, or the by mentioning the points or calculating the points or something. So just please try to share that any of the worksheet or the paper or something you got from your instructor, so that I get to know about the paper code, so that we can practice accordingly. So this is very like this is mandatory to practice accordingly, because We have a lot of data on the Google, on the internet. Our students are appearing from the IGCSE, from the AQA, from the Dixel, from the GCE. So we need to be more focused on our board. In substitution method, try to solve the same questions using like you just need to solve 5 questions from the. You can choose any random, like you can choose any random questions from the worksheet, same worksheet, and solve those using substitution method. Try to solve the question which you have not solved using elimination method. Yeah, last five, and solve this question number 4 which we did in the lecture, during lecture, using elimination method. The same question, the Robbie pays $10.80, this one. Okay, I'm gonna share the slides right after the class. So this was all from my side. If you have any questions, you can ask, please. Okay, but I need to ask you something. Like I need a very honest feedback from your side, so that if there is something we need to improve, I should improve. Then please share it with me so that I can improve in my teaching to like make my teaching, my lecture more effective for you. So if you feel something, please suggest. Okay, just tell me about that. Whenever you feel like I'm speaking it fastly, I'm taking it fastly, just mention here, sir, please repeat it, or anything. Just mention it. I will, I just basically I was doing it to save our time sometimes. Like when I did the first question, if you noticed, when I was doing the first question, I was doing it step by step. So this is this was this to add this, to subtract this, to multiply this, to divide this. But when I'm solving the second or the third question, sometimes I do this intentionally. So I just increased my speed in the second or the third question. So this is basically when we are doing the same things. So if you feel any difficulty, you should mention it. You can mention at any time, like during lecture, if you feel any difficulty. Even sometimes, if you feel that how did I wrote that 2 plus 2 is 4, you should ask. If you're not asking anything, you're not learning. So you can mention. Yeah, I would love to answer your questions. So this is all from my side for today's class. I think we should goodbye to each other. Say goodbye to each other for today's class. If you got any questions during while you are solving this, you can email me directly and ask your question. Just attach a picture. Sir, I'm facing problem in this question. Can you please guide me? I will try to answer you as soon as possible. So take care of yourself. Bye bye. Thank you.